Hi guys, this is a calculus video 7-9 for Monday, March 6th. There's going to be no associated homework, and this lesson is on the inverse derivative theorem. So here it is, and this is a formula to be memorized. If f is differentiable, so meaning that its derivative exists, and g is the inverse of f, then g prime of x is equal to 1 over f prime of g of x. Okay. Now last year, or maybe the year before, I just kind of gave the formula without proving it, but the proof is like really simple, so I crossed that off. I'll never have you prove it, but this is, it's really easy to see where this comes from. So the proof goes like this. So f and g are inverses. All right, so we start off assuming that. Therefore, f composed with g of x is equal to x. That's how inverses work, guys. If you do a composition of them, you just end up with the input, with whatever input went in to begin with, because they reverse each other. Whatever g does, f reverses, and vice versa. So if you did g composed with f of x, the same thing would happen, okay? So if this happens, guys, now if we take the derivative of this equation, this is a composition of functions, so we have to do chain rule. The inside function is g, the outside function is f of blank. The derivative of the inside function is g prime of x, the derivative of, so times, derivative of the outside function is f prime of blank, but this works like this, whatever was in there before goes back in, so g of x goes back in. So that's the derivative of the left side of the equation. Now the derivative of x is just 1. And then you just divide both sides by f prime of, by this factor right here, and you end up with the formula. Okay, so it really makes a lot of sense. And so now we're going to use the formula and do two examples. One is pretty straightforward, and the other is a little more, takes a little more thinking. So example number 2, if f and g are inverses, okay, inverse functions, and f of 0 equals 4 and f prime of 0 equals -2, find g prime of 4. So we don't know g, we don't know f, and they're asking us for g prime. So this is a situation where you should write down the, if you've got inverses to begin with and they're asking you to find the value of one of their derivatives, then you should try to use the formula. So so we've got g prime of 4 is equal to 1 over f prime of g of 4. All right, so I just used that formula right there. Okay, so all we've got to do is we've got to know what g of 4 is, and then that we're going to plug into f prime. Okay, so you don't have to do it like this, guys, but oh, actually, no, let's do this. Okay, so let me try this. All right, so let me go like this. I was going to do something different, then I just had an idea. Okay, so since these are inverses, guys, so f of 0 equals 4, right? They're telling us that. Therefore, g of 4 equals 0. All right? So this is a property of inverse functions. The domain and range, they switch. Okay, well, whatever's the input of one is the output of the other when you plug in, the output up there. Okay, so the other way that I was going to do it, guys, so let me just show you another option, is to think it through with tables. That's what I was going to do. So if you do like a table for f, a table of values for f, and a table of values for g, x, y, x, y. Okay, so I'm going to take what I know, this ordered pair, and I'll put it in this table, and that means that the corresponding ordered pair in the G table would just go like that. All right, so this is another way that you could maybe think through this same idea. Okay, so we've got that this is 1 over f prime of, we just figured out that G of 4 is 0, given this information and the fact that these are inverses. And then they gave us f prime of 0. And these problems will usually work this way, guys. They're definitely giving you what this ends up being, usually. And then this is 1 over negative 2. Whoops. Okay. So 1 over negative 2. So this is G prime of 4. Alrighty. Now let's do another one. So given that f of x equals x to the third minus 5, find the equation of the tangent line to the graph y equals f inverse of x at x equals 3. Okay, so let's think this through. Let's first of all do this, guys. Because the inverse notation is kind of hard to work with, let's make the notation easier and let g of x equal f inverse of x. Okay, this notation is easier to work with, and also this is the notation that shows up in the formula that we proved on the other page. Okay, equation of the tangent line. Anytime that you're asked to find the equation of the tangent line, I think that this is the first thing you should say to yourself. Point of tangency, okay? And then over here we need the slope. Okay, we need the point of tangency, and we need the slope of that tangent line. Now, they're asking us that we want the tangent line to the graph of f inverse, okay, of which we called g of x. So the derivative of g, that's what's going to give us the slope of the tangent line for any point on it. So this slope is going to be given by g prime. All right. Now, what do we know about the point of tangency? We know its x-coordinate is 3 something. And we don't know g, so we can't find g prime. But we do know f, and we know that f is its inverse. All right? So what you could do, you could actually find this inverse function, guys. That's also an option. But let's use the formula instead. Alrighty, so let me use these things to figure this out, all right? Or actually, let me do this. Okay, so we want, all right, so g of 3 equals what? Okay, so how could we figure this out? Because that's what we want there. We'd figure it out by using this property of inverses, I guess. F of whatever that is going to equal 3. Okay? So I can just take f of x, what I've got up here, and I can set it equal to 3. So x to the third minus 5 is equal to 3. So x to the third equals 8. So x equals 2. All right, so the question marks for both of them are 2. But then if you want, here's the other option. This is how I used to figure it out with my previous students. We would do a table for f and a table for g, whatever works for you guys, x, y, x, y. Okay, so we've got, so this is what we want. So then we'd go like this. And then we would do, you know, this information down here would allow us to set this up. And then we would just solve. Okay, so 2 and 2. Alrighty, so the point of tangency is 3, 2. And then g prime, we can use the inverse derivative formula, okay? F is its inverse, we want its derivative, we can use the inverse derivative formula. So g prime of 3, okay, because we want the slope of the tangent line at this x-coordinate 3. So g prime of 3 is 1 over f prime of g of 3. Okay? So this is 1 over f prime of, we already figured out before that g of 3 was 2. So I just need f prime of 2, and that would be the denominator. So I know that f is this, so I'll just take its derivative. So we've got f prime of x is 3x squared. So f prime of 2 is 12. So this is 1 over 12. So now that this chart is filled out, I can use the point slope formula. So now I can say y minus 2 equals m x minus 3. Okay? And there it is. So this takes a lot of like thinking backwards and forwards. If you don't know, you know, this relationship about inverse functions, then it'd be pretty difficult. Alrighty guys, so there's that. There's no homework with this, and I will see you soon. Bye-bye.